All right, so welcome today to day 9 of Advent of Code walkthrough. And this one, we will have a very famous problem. It's called Travelling Salesman, so I was reading offline. The idea about the puzzle today or of day 9 that Santa needs to deliver the present this year for multiple cities. And these cities or locations, we need to find the shortest distance between them and what we are given so the distance between different ones. So from London to Dublin it's 464, and from London to Belfast it's 518, and Dublin to Belfast it's 141. So we need to calculate the shortest distance between them, and this is the idea of the traveling salesman problem. So it's a really famous problem, and it has so many applications, and it has so many different way to approach the solution, some heuristic or some like specific or actual solution ways. And the easiest or more direct way, which we'll talk about it in this video, is the brute force approach, which we calculate all the possible routes and options, and then we calculate what we need, like shortest distance or whatever. And yeah, for this one, for example, we calculated, we have the distance between two cities, and then we need to all the possible routes, and then we need to find the shortest one of these routes. So they don't need the route itself; they need only the distance that we need. So this kind of problem is called the graph problem. So we have something like the city A and the city B, and let's see the city C. And between these cities we have a connection. So in graph theory, this called as a node, and this is called as an edge. So the edge is usually connecting two nodes together. So this basic graph, it's non undirected graph or undirected. So the distance between A and C, it's the same distance between C and A. It's the easiest one, and it's more direct approach. It's the more direct one. So how to approach the solution? So to calculate all the possible options, it's called permutations. So for our case, we have three cities. We have A, and then we have B, and then we have C. So this is the start point. So this is the start point. How to calculate to start. Uh, we can even start from the city A, or start from the city B, or start from the city C. So this is the only options that we have. And when we go to the city A, we can actually go even to B, or we can go even to C. And for B, we can go to A, and we can go to C, and from C we can go to B, and we can go to A. So this is the only possible route. So if we just check the route, so we have now even the start, okay, A, B, and C. So we have, I think this is wrong now. So from A, we can go to B, and then from B, we can go to C. And from C, we can go only to B. And if we go from B to A, then we can go only to C. And if we go from B to C, we can go only to A. And if we go from C to B, we can go only to A. And from C to A, we can go to B. So the idea behind it is, sorry, it's not the, okay. So the idea behind it is to start from one city, and then we can calculate how we go to the other cities. And since it's three cities, it's easy. So we have this option, and then 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 we have this option. So we have six permutations. So how we calculate this one? It's really just the factorial. So it's the number of cities that we have is 3 factorial, which is 3 multiplied by 2 multiplied by 1. And for 3 cities it's okay. For 4, 5 until 10, I think it's okay to calculate it with this way, even if it's heavy on the computers, like the old computers, not the current ones. But this is the easiest solution. The other better solutions that we can use, we don't need it for advent of code. So let's jump directly to the code and start how to solve this problem. So okay, let's create the solution files. Forgot to create them today. So it's package 9 on it, register. So it's today 15, it's day 9, and we need solve. Okay, function solve. We have an input from string, it's solve. Okay, so um, let's check the input that we have so we can copy it. So we have the input is London to Dublin. Let's copy it as a solution file, the input file. No, this is the previous one. This is the one today. Okay, so how we will start this one. First of all, we need to parse it. Actually, it's the easiest way. We need to parse it. We need to get the London, Dublin, and then we got the cities between them. So the easiest way is to have it as an array of distances from the city A to the other cities. So we can even have it in a two-dimensional array, or we can have it as a map. So we can have map, which is from the city from, and then we have the distance, or the city we went to. So it's also a map. So it's a map of string, and then the it's an int. So it's unsigned int because we have distances, so we don't have minus, we don't have negative, so we just have positive values. And then this is, let's put it here. Okay, so then what we can do, we need a parse function. So function parse, we need to input the line from string. So for this one we need lines as always. Input dot split. So the split returns array, but I learned something over the weekend. We can use something called split reference, split sequence. So it's instead of using array and index, we just use a sequence. So we can have the input. We need to split the input, and then input, and we split it over string. Then we can go for line in range lines, and then for each line we need to parse the line. So parse the line, what we need to put in the line. So we can have the since we need to parse the line, we do something like the previous one. So we pass also the distances to fill it. So we can have it as distances, and then we can have it also as a map, as a reference, map string, and then unsigned integer. Okay, so we need to pass the other array. So we pass the distances as a reference. So what we have, so we have London to Dublin equals 1, 2, 3, or whatever value. So what we need the city from, and we need the city to. So from London to Dublin, and they are, and also we need the distance, and it's empty, and it's unsigned int with 0. So this is what we need, and we do parts. So line dot split, or what we can do, we can use scanf. We can use scanf, parse the line to first city to second city equals d, and then it's a reference for from, and then to, and then d, its distance. Okay, so it's not parts anymore, it's the number of uh, um, parsed entry successful and an error, and maybe we can do an if, and then if number not equals 1 2 3, or error not empty or not nil, panic, something went wrong, parsing plus line. So the easiest way. And then what we need to do, so is that since the distance is from two cities, so if it's the city is not found, we need to create it. So we can use something like distances, but we cannot. So it's distances from equals, it's not like this. So what we need to do, first we need to check if the city is found or not. So if distances from not equals nil or equals nil, if it's empty, we need to create it. So distances from equals make map. We need to create a map of string and unsigned int. Yeah, so this one we need to put it in brackets. I learned this the hardest way, so we always put the reference if it's array to brackets. So now it works, and I think we need to do the same for when it's 2, and then so this is the first step. We initialize it, and then we use distances from to equals the distance, or just distance. Oh yes, it works. Yeah, but also it will not work. We need to put it between brackets. Oh, the mic distances. Okay, and also we need to create the opposite. So since it's the distance from Dublin to London is the same from London to Dublin, we need also to, so like this. So London to Dublin, and then Dublin to London. Okay, so now it's correct. We don't need to return anything, we just have it. So let's just print it to see how it is. We need to print the distances. Okay, go run d9. Okay, so no solutions. Okay, I forgot to put it in a main. So So it's correct. So it's a map from Belfast to Dublin. It's 140. From Belfast to London, 518. It's correct. So um, this is the first step. So the second step, we need to calculate the possible options or the permutations. So the best way to do it, as I explained, so to start with the first element, or to pin one element and do the other one. So let's go to the whiteboard. So how we calculate it. So since we have like three items, like or as many items we have, uh, if we have only single element, so the permutation of this single element is only one element. And if we have a or b, if we have two elements, so the permutations is ab or ba. So how to solve this one? So we put a, we take a, the first one, and then what's the possible options? It's only b. And then we take the other one, and then what's the possible options is a. So we combine them, it's b a b. And imagine that we have three items as I explained before. So we have a, b, and c. So what we take the first one and we pin it, and then what's the possible options to go? We can go even to b, or we can go to c. Then since we have two arrays, we can split it to solve it as its own. So we solve the bc alone. So bc, we can go to two options. So it's bc or cb. Then we can go back and combine it with a. So it's a plus bc and a plus cb. So this is 1, this is 2. And this is only for the first element. So the second element is uh, b, and from b we can go to a, or we can go to c. And then so from b we have ac, and then from ac, how we can go even to c, or we can go to a. So we have bac and bac and bca, and so on. I will take the recursive route. It's more direct, more straightforward to do. So let's call the function permutations. Get permutations. And what we need only the city's names. So we don't need all the permutations. We don't need all the distances. No, actually, we don't need the distances. So where's the solve? Ah, not this one. Oh my god, I'm crazy today. Okay, so this one. So we need the cities. We need something called cities. Make. Let's make it as a string, and then it's this one. 0. And then for key range distances, cities, append cities, okay, or city, let's call city. And we can check if we have the cities correct with just a print cities. Okay. Let's comment it a second. Yes, we have the cities correct now. and then let's get permutation. So what we need the cities actually. We need the cities, which is slice of string. So how to stop, since we have a recursive, so what we need to do, we need to a way to stop it. So as I explained, so the permutation for a single element is this element. So if the length of the cities is 0, so or is 1, so we need to have return cities. cities but what we need to do actually, let's go to the whiteboard a little bit. What we need to do, we need way to store it. So for a, b, we need to calculate, we need to all the roots. So it's array of array. So the first element is ab and the second element is bc. So this is array of array. And for single element, so we have to put this element inside another array. So it's array of array. And this is not the best way to do it, but advent of code, just we need to solve it. So we need to return array. We need to return of string. So how to do it? We do and from cities. So like this. And now we need to go from for we don't need the index, so we just index or city, the value, range, cities. So what we need to do, so we need to pin one of them. So let's first put the results. It's an array of strings, make 0. We don't need this one anymore. Okay, so this is the result. So how we want to do, we need to pin one city. So we start from the first position, we take a, and then we need to what is the remaining cities. So for this one we need to create the remaining, for example, remaining cities. It's array strings, and then if it's a b, we need to remove a, so we need only a. So we need the links of it to be the cities cities minus 1. And what we can use, I learned that we can use a copy. We can use copy to copy from slice to another one, or we can use append. So both of them are good options. So we can use so we can copy to. So the copy command is copy to slice a slice b. So the second parameter. So I need to copy to the remaining. I need to copy from cities. I need to copy from the first position until the position of the current city. So if it's 1 or if it's 0, we just copy the first one, or from second one, third one, until we reach all the cities. And then also we need to copy the rest of the array. So if we have, go back here, so if we have array of a and b, and C. Let's go A, B, and C. So we need to create another array. So we need to pin this one. So we have the city is A, and then we need to have another array. The remaining should have B and C. So this is easy. We just take the rest. But imagine that we have now A, B, and C, and we are at position 2. So what we need to do, we need to go the city. So the city is B, and then we calculate the remaining. So the remaining is array of length equals to 2. And then for this one, what we need to do, we need to copy this one. So we need to copy the array from this position, and then we need to copy this position. So we need to copy this and this, not to this one, to the remaining array. So the remaining array equals now A, and then we need to put in the remaining array C until we have it. Then we need to calculate the permutations for this array, and then how we goes for the recursion. Okay, so we need to copy to the remaining at position A the cities from position A plus 1, because the city is at the 1 to the end. So in this way we will have the array, and then we have permutations, for example, or remaining permutations, get permutations for the new remaining array. So now what we have an array of the extra element that we calculate for 2 elements, and then this one will have 4 arrays, like we'll have 2 arrays. So we need to combine, or we need to stick the first one, the first array, to the other array. So what we need to do, we need to have the so we have city, for example, is A, and then remaining permutations is something like BC and CB. What we need to do, we need to append A for each of them. So we need to have something like A, ABC, and then we need to have A, C, B. So how to do this one? We need to do append. So we need to do remaining. We can append it to the results actually. So results equals append to the results this new array. So the new array, so this one is new permutations equals. So we need to append to the city, which is array. So it's something like city. We need to append to the city. It's not array. City. We need to create a city array, and then we need to remaining permutations. So why it's not working? Okay, so The remaining permutation is array of array, and then we need to append this array to each element of this array. So what we can do actually, we can do something uh, different. We can have for we don't care about index element of range remaining permutations remaining permutations. We need this one. Let's have this one so as make means 0 for now. So permutations equals append to permutations. We need to append the city and the element, something like this, and then we need to append this one to the results. So we need to have uh, this one we calculate ABC and this one we calculate ACB, and then we need to combine this one to each one of them to be an element in the results, and then I think we are done. So then we need to return the return results. If it works, my device will not freeze. So let's see it. Results, permutations, get mm, oh, I wrote it somewhere else. It's funny when you just record. So it's here, different functions. Okay, so get permutations. We need to get permutations for the cities. Okay, so this is the cities, and then we need to print the permutations. Let's see how it will goes. Actually, it's nice. So we have London, Dublin, Belfast. No, it's not correct. So not correct. So we have a list of a list of a list. Okay, so what went wrong? Print line. So we need to append this one to this one first. And then we append this one. Oh, now we have it correct. So we need to do this one. We need to append this one to this one directly, and then now we have it correct. So we have London, Dublin, Belfast, London, Belfast, Dublin. Okay, we have everything now, but I'm not sure if we need this one actually. Actually, I can do this directly here. So append to results, not the permutation, but append this one, something like this. Permutations, remaining permutations. No, I think it works. Okay, so now we have all the possible options. It's correct. Now we need to calculate the minimum and the maximum. So what we need to do, function get minimum, and then minimum we need to have the permutations, which is array of string, and then we need also the distances, which is a map of string and then map of string, and then it has unsigned int, and then the value is unsigned int. So the best way to get the minimum, actually to set the minimum, is the maximum value, and then we calculate the first one, and then we check if the minimum is less than this value, or the calculated value less than minimum, we put the minimum, otherwise we put the other value, normal comparison. So minimum equals, so there is a small trick here. It's done. So we need the signed in of 0, but we remember from the last, or the like two solutions 2 days ago, we have the not bitwise operation. So if we put something to 0 and then we put the bitwise operation not, this will have as a 0 0 0 0, and then we will put null or not. We will have 1 1 1 1 in a binary representation. Then we will have the maximum value. So mine now is maximum. So this will put min equals maximum value in uint. Now for each permutation, so for each for we don't care about the index. Oh, we actually care about the index. Permutations, we don't care about the index. Cities, range, permutations, or actually they are not cities, cities path, or cities, yeah, cities, just cities. So now we are at the first one. We since we have the array as London, Dublin, and whatever, we need to collect the first one, and then we need to calculate the distance. Then we need to take the second one, and we need to calculate the distance. So these cities are something similar to this one. So what we need also, we need to go to each one of them. So for city in range cities, we need to calculate the sum, or the distance. Distance, this is we need to have the distance for these cities as a 0 0. So for each city we need to have distance equals to distances from the city and the next city. So actually we need to go with a different loop. We need to go from equals 0 to minimum the length of cities is -1 and then plus plus. So we need to have the distances of cities position I and the next one. So the first one we need to calculate the distance between London and Belfast, then from London to Dublin. So we are going 2 times, it's the length of array -1 and then the cities I plus 1. So this is a distance. Now we have a distance for a single array, and if the minimum is less, if the distance is less than the minimum, we don't need the distance, we need the distance not as an int. So let's keep it as unsigned int, because I think we will have problems with calculations if the distance less than minimum. Here we need to have unsigned int 0. So now minimum, set the minimum equals to distance. Simple as this. When we go for over the array, we return the minimum. So for these options, what we have to see, I don't remember the solution. So we should have 605. Let's go and check it. This solve, where's the solve? Yes. So let's say minimum equals get minimum permutations and distances, and then solve print f part 1 d and then minimum. So let's go one line and then let's try it. Nice, it's correct. So it's 605 correct. So let's now solve the actual problem. So let's get the input and then we go to this one and then we calculate. It's 207. Let's go. It's 207. Yes, it's correct. So let's go to the part 2. Part 2 the next year, just to show off, Santa decided to take the route with the longest distance instead. Okay, nice. He still start the end of the 2 different locations he want, and he still must visit each location exactly once. Okay, for example, given the distance above, the longest one is 982. So let's copy this one, or we can solve the actual problem directly. So the longest distance is actually exactly the same as the minimum, but just small differences. So in Go, we can do something very nice. We can have the function return 2 values, and I want to return the minimum and maximum at the same function, so I get min max. And what we need to do, we need to put the minimum and the maximum is exactly similar but the opposite thing. So for a start, we start with maximum equals to 0, and the minimum start with the maximum value, and here we calculated the distance once, so we don't need to calculate it again. So if the distance is less than minimum, we take the minimum is distance, and the same if the distance more than the maximum, put the maximum to distance. So it's the best way to solve it. And what we return min and max. Min and max. Nice. This is to int. And here what we can do something very nice. We can have something like min max max, and then we can get min max. So this is a part one. This is a part two. Max. Let's run it. 207804. Oh, not you again. 204804. 8804. Nice. So it was a long one. Day 9 is done. See you tomorrow in day 10.